Hey everyone, thanks for tuning in to Test Tube Plus today. I'm Trace, and this is episode 1 of 5 in our new series on fire. Like, fire, flames and stuff. Subscribe so you get all of the episodes in this series. Trust me, it's gonna be really great. You can also check us out over on iTunes if you want to listen to the series. It comes as one podcast. It's easy to find. But this week, we're gonna talk about what fire is exactly. Like, think about it for a minute. Do you know what fire is? What makes the flames? What are they made of? And when did fire become a possibility here on Earth? And when did we harness it? Also, we're going to talk about burns and cooking and firefighting science, because there's this whole branch of science related to fire science. We're going to talk about all sorts of stuff, even fire not on this planet. It's going to be really, really cool. But first, let's define that big question. What is fire? We've all been around fire. We've either made fire, we've seen fire, we've lit matches, all sorts of different things. Basically, fire is a chemical reaction. It needs 3 things. They are referred to as the fire triangle. Oxygen, that stuff around you, you breathe it in all the time. There are other oxidizers that can produce fire as well, but that's the big one, nitrites, chlorates, nitrates. The most common, though, oxygen. It also needs fuel, which is like solid wood or gasoline or any number of other combustibles, methane, so on and so forth. The third is heat, and it might seem kind of counterintuitive that heat would be part of the triangle, but you need heat to start fire. Yes, it generates more heat as it goes, but the heat is part of the fire triangle. 3 things you need to start fire. Heat could be from the friction, like when you strike a match, or it could be from an electrical spark or from a chemical reaction that releases energy. There's also another segment which people add that could be the fire tetrahedron. I know we just got to triangle and we're upping the game already, but stick with us. The 4th element is redox, or a rapid oxidation, a chemical chain reaction, essentially. The oxidation is the interaction between oxygen molecules and something else. So one of the things loses electrons. Think iron, right? When iron is left out into the environment, it will rust. That is oxidation. It's exposure to oxygen. And it loses electrons to the oxygen in the air. So when heat is added to fuel and oxygen, eventually the fuel source will lose electrons and oxygen will gain them. This molecular transfer creates heat and or light, which in turn will then create fire. Now, the reason some things catch fire and metal just would rust is because the oxidation has to be rapid. If the heat made by this process can't be released faster than it's being created, it can't get dissipated faster than it's being built up behind it, then you have rapid combustion, and the rapid combustion is what eventually creates fire and flame. Now, this is still just kind of how we make fire, right? As the fuel heats up, let's say the wood, for example, like in a campfire, it gives off a gas. Sometimes you can hear it when you're sitting next to the fire, a hissing sound. And this is called pyrolysis. The gas escaping is actually what's being lit on fire, not so much the actual wood. The gas is what makes the flame. The pyrolyzation process takes the oxygen out of the wood, and what is left is mostly carbon. And that's what you see when you are done burning a campfire. All of the little chunks are charcoal, mostly carbon, the ash byproduct of wood, the impurities that cannot burn, calcium, potassium, those sort of things. Now that the fire is going, though, it gives off heat, and heat is what helps the fire continue to burn, to pull more oxygen out of the wood, to get more fuel and get more oxygen underneath it as the heat cycles the air around it. It basically ensures that the fuel remains at the ignition temperature, it's hot enough to keep burning, and the flames produce more gas, and so on and so forth. You might notice that flames always seem to go up. Flames being hot means they're less dense than the air around them, right? They will naturally have more energy, and they'll move upwards into trying to cool off and get a lower pressure. And then colder air comes in underneath and heats up, and you end up with this cycle. It's also why fire spreads upward. It also spreads by heating things up around it sometimes. So if you have a really big campfire, sometimes things on the ground nearby can catch fire as well. That's why you have to clear the area before you make a fire. Now, if you want to put these fires out, all you got to do is break that triangle or break the tetrahedron. You get rid of the fuel. That's what firefighters do by cutting lines or blowing up buildings in the way of a massive fire. You can cool the fuel down by throwing water on your campfire, something like that. You can take away the oxygen, so putting a jar over a candle would do that. Or you can break down the chemical reaction. So if you use a fire extinguisher that has CO2 in it, you're snuffing out the fire by removing the chemical reaction from the area. What fire is this chemical reaction, this exothermic reaction. It's releasing heat into the air. And that heat, in turn, creates more fire. So now that we know what fire is and we know all this stuff about the chemical reaction itself, where did this come from? Like, how did we learn to harness it and use it for our own purposes? And how did we learn to take this chemical reaction? On top of that, when was the first fire? We'll find out more about that tomorrow, so make sure you subscribe for more Test Tube Plus. Let us know down in the comments how you feel about fire. I feel like I could just stare at it for hours. You feel that way? Is that just me? Also, make sure you subscribe so you get all of our videos. And thank you for watching Test Tube Plus.